using Excel sheet to formulate ration. The idea is to solve a series of equations, minimize or maximize parameters, feed cost, any nutrient level. Corn contain example of the problem. Corn contain 88.8 percentage protein, 0.4 kilocalorie per kilogram, cost $16 per 100 kilograms, an example. Soybean meal contain 48 percentage of protein, 2.44 kilocalorie per metabolizable energy per kilogram. Cost is $23 per 100 kilogram. It's an example, and it's roughly the cost changes with time. The kilogram of corn plus the kilogram of soya bean meal should equal to 100. The feed should contain exactly 2.997 kilocalories metabolizable energy per kilogram and at least 23% protein. What is the least expensive combination of the corn and soybean meal that meet these restrictions? This is the question, and we need to answer it by putting the equations and solve it in the Excel sheet. What is the least cost for formula that meet these requirements? X pounds of corn, Y pounds of soybean meal, X plus Y equal to 100. 3.43 X plus 2.444 Y more than 2.92. 8.8 X plus 48.5 Y equal to 23, and this is the linear algebra. This is we put the here we make x-axis and y-axis. In the y-axis we put the kilogram of soybean meal, and here we put the kilogram of corn, and here is the linear equation, and this is the graph, the line which describe this equation, and here its solution, and here also the number 2 equation, and here the solution by using graphical solution. Shading indicates that anywhere above this line satisfies the energy restriction. Graphing to find solution for 2 ingredients and 2 nutrients is possible. More nutrients or ingredients make the solution very difficult to find. Computer programs like Excel and several commercial products make least cost feed formulation feasible with many ingredients and nutrients. The feed composition and ingredient. Here the ingredient, number of ingredients, and here we find the nutrient. Enter the feed composition, cost, and the limits data in this window. Data can be stored on the bottom of the pages. We can by this change the pages. Clicking on the nutrient tab and windows for the nutrient limit, enter the nutrient requirement and the toxicity data in this window. Here the formula, or open the mean formula window. The graph here on the feeds page tab, open the window designed for printing. Formula detail, here the print, mixing sheet, ingredient unit. The other table lead to the spreadsheet with the stored data. Here the stored data. The corn for ingredient, soybean meal for ingredient 2, the corn for ingredient 1, soybean meal for ingredient 2, energy for nutrient 1, protein for nutrient 2, the simple ending for formulating ration and balancing the energy and the protein. Here the active ingredient, here the code, soybean meal, you can put wheat, barley, anything. Here the energy, here the protein, and here the cost, as we mentioned before, and here the energy and the protein, and we put the limit for nutrient on the nutrient spreadsheet. Here the tools to solve the entered problem, go to the formula spreadsheet and choose tools, solve and solve. Solve this problem we got here, tool, and here solve, and here the program equation and the inequalities for the enter, and here we get the results. Here the result, no change in this window. We get the amount result are displayed on the formula spreadsheet. On the sheet spreadsheet is ready for print. On the graph spreadsheet also there is a graph for expressing. Here enter new ingredient on the ingredient spreadsheet. Here when we get an optimal solution, go to the heat space window. Before making any change, copy the percentage of the corn, percentage of soybean meal, formula cost to chapter. Change the maximum protein. After solving the problem with no maximum on the amount of the protein, again copy the percentage of the corn, percentage of soybean meal, and formula cost to the chapter worksheet. Here we add the new nutrient data on the ingredient composition spreadsheet, nutrient, protein, here the nutrient, energy, protein, sodium chloride, etc. Adding